Hi everybody, Mrs. Gifford here on a quick lesson about probability of independent events. So let's get right into our definitions. And first thing when we talk about is what is probability? It's the likelihood or the chance of something happening. And when we write probability, we're going to write it as a ratio or a fraction of what we want over the total things that we are talking about. When you see independent event, that's when two things can happen at the same time. For example, flipping a coin and rolling a die. So let's take a look at this first example. We have this bag of different types of sports balls. We've got baseballs, pool balls, tennis balls. And we're going to find each of these 5 probabilities based on what we see in this bag. Now remember, probability of what we want is going to be what we want over the total. So in each of these scenarios, this capital letter P stands for probability, and the first one is the tennis ball. Well, the first thing we want to do is count how many tennis balls are in our bag. We've got 6, and then we want to count up the total. So I know there's 6 tennis balls in the bag. I know that there are 8 pool balls in the bag, and I know that there are 5 baseballs in the bag. So for a total, 5 and 8 is 13, plus 6 is 19. So I have a 6 and 19 chance of pulling a tennis ball if I was to reach into that bag. So if 6 out of the 19 are tennis balls, how many are not tennis balls? Well, then I go back and look at my 5 and my 8, which is 13. And again, I have a total of 19 in the bag. Take a look and see if you can figure out the probability for pulling a red pool ball as we are looking at it. Now as I look at it, there are 8 pool balls in there, so a common mistake might be 1 in 8 for this. However, we're talking about the entire bag, so the probability of pulling that red pool ball is just this one pool ball out of the 8 that are in that bag. And how about example D? How many, if we reached in and got a baseball or a tennis ball, again, we still have 19 in that bag, but how many are either a baseball or a tennis ball? We have our 5 and our 6, which makes 11. And then last example of our probability, take a look at the bag. How many footballs are in it? There are 0 footballs in that bag of 19, so we have absolutely 0% chance of pulling a football. Now, what happens if you have a simulation where you have 2 different things happening, where you spin a spinner and roll a die? Well, you can figure out those particular combinations based on the probability of each of these situations. Again, we need to keep in mind that there are 5 sections on our die, and on our spinner, and there are 6 on the die. So we want to figure out the probability of getting a green when we spin and a 5 when we roll. There's 1 green out of 5, and there's 1 5 out of 6 on the die. When we do this, we are then going to multiply those 2 fractions together. So it would be a 1 in 30 chance to get a green on the spinner and then a 6 on the die. Moving on to letter B, we do the same thing for spinning a white and a 4. There are 0 white sections out of the 5, and there's 1 4 out of 6. However, I know that 0 over anything is going to be 0, so there's absolutely no chance of us spinning a white wedge and then pulling or rolling the 4. Last one, what's the probability of getting a blue and then an even number? So we're going to do them separate. You have a 1 in 5 chance of getting the blue. And then thinking about a die, the even numbers are 2, 4, and 6. So that's 3 over 6, which I know turns into 1/2. So I have 1 in 10 chance of getting the combination of a blue with an even number. So that's it, folks. I want you to take a few minutes to write your summary of 3 to 5 sentences of what the lesson was about, what did you learn, and what's some example that you have related to this lesson. Happy probability!